Hello everyone, this is our fourth lecture for Chapter 6, an introduction to probability. In this lecture video, we will discuss how to calculate probabilities for independent events, mutually exclusive events, and not mutually exclusive events. We will begin with the multiplication rule for independent events. Remember that independent events are when one event has no effect on subsequent events. Suppose that you flip a coin twice. What is the probability that your coin lands on heads on both flips? Put another way, what is the probability that your coin lands on head on the first flip and your coin lands on heads on the second flip? We can create a sample space that lists the outcomes of this experiment very easily. Let's look at that. In flipping a coin twice, where H represents the outcome heads and T represents the outcome tails, we can obtain a sample size, or a sample space equal to heads, tails, heads, and tails, right? There is one outcome, one out of four possible outcomes where heads, or four heads with both flips. Because each outcome is equally likely, we are looking for probability of heads on the first and second flip. So we're going to take this apart for a second. The probability of heads on the first flip, we're going to call that probability of event A. Heads on first flip. Probability of heads on second flip, we're going to call that probability of event B. Remember, these are independent events. The multiplication rule for independent events is probability of A and B equal to probability of A times the probability of B. So the probability of A is equal to 2 out of 4. So probability of A is 2 out of 4, right? Probability of A of heads on the first flip is 2 out of 4, right? Which is 1/2, which is equal to 0.5. Probability of B, which is heads on the second flip, again is 2 out of 4, or 1/2, which is equal to 0.5, right? Now we take these two probabilities and we multiply them because they're independent events, and we use the multiplication rule. So probability of A and B is equal to 0.5. Whoops. Let me erase that real quick. 0.5 times 0.5, which gives us 0.25, or 1/4, 1 out of 4, which is equal to 0.25. The interpretation here, there is a 25% probability that our coin will land on heads for both coin flips. This does not mean that 25% of our 2 coin flips must land on heads. What this means is that we expect 25 out of 100 times, or a 25% probability for our 2 coin flips to land on heads. Remember that probabilities are always expectations. Now let's explore the addition rule for mutually exclusive events. Remember that mutually exclusive events are when two events cannot happen at the same time. If A and B are mutually exclusive events, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. However, remember that with mutually exclusive events, probability of A and B is always equal to 0. So the probability of A and B equal to 0, which means the addition rule for mutually exclusive events is simply probability of A or B equal to probability of A plus the probability of B. In other words, the addition rule for mutually exclusive events states that if you have two events that have no common outcomes, the probability that one or the other occurs is the sum of their probabilities. The addition rule for mutually exclusive events can be extended to more than two mutually exclusive events. In general, if events A, B, C, and so on each have no outcomes in common, then probability of A or B or C or so on is equal to the probability of A plus probability of B plus the probability of C plus the probability of so on and so on. Let's take a look at an example. We'll take a look at a deck of cards and the addition rule for mutually exclusive events. Suppose a single card is selected from a standard 52-card deck. We will use the theoretical method for calculating the probabilities because the outcomes are equally likely and easy to count. So let's calculate the probability of the event A equal to drawing a king. A standard deck of cards has 4 kings, so the probability of drawing a king is equal to 4 out of 52, which is equal to 0.0769. Now calculate the probability of the event A drawing a king or B drawing a queen. We use the addition rule because the events are mutually exclusive. You cannot simultaneously draw a king and a queen. A standard deck of cards also has 4 queens. So the probability of drawing a king, we already said, is 0.0769. The probability of drawing a queen is 4 out of 52, and still 0.0769. This is assuming that we are replacing the cards. The addition rule for mutually exclusive events is probability of A or B is equal to probability of A plus the probability of B. So we would take the two probabilities, add them together, and that would give us 0.1538. So 0.0769 plus 0.0769 is equal to 0.1538. We would interpret this, or the interpretation is, there is approximately a 15% probability that we will draw a king or queen from a deck of 52 cards. Again, we expect that about 15 out of 100 draws, or 15% probability, to pick a king or a queen from the deck. Let's try another example. The probability that someone in the human population has an AB blood type is approximately, so let's do this, AB blood type is equal to 0.04 or 4%. The probability that someone in the human population has an O blood type is approximately 0.45 or 45%. Knowing that each individual can have one and only one blood type, we're asking A, what is the probability that a person has an AB and an O blood type? And B, what is the probability that a person has an AB or an O blood type? So let's start with question A. The events having AB and O blood type are mutually exclusive. An individual cannot have both blood types. So the probability that a person has an AB and an O blood type is 0. So probability of AB and O is equal to 0. Probability of AB and O is equal to 0. That's always the case for mutually exclusive events. Now for question B. Because these are mutually exclusive events, we can use the addition rule to find the probability that a person has an AB or an O blood type. AB or O blood type. So we take our probability that someone has AB blood type, which is 0.04, plus the probability that someone has an O blood type, which is 0.45. Add them together and we get a probability of 0.49. So the probability that someone has AB or O blood type is equal to 0.04 plus 0.45, which is equal to 0.49. How do we interpret this? The interpretation is there is approximately a 49% probability that an individual has an AB or an OB blood type. Again, we expect that about 49 out of 100 individuals, or 49% probability, that someone has an AB or an O blood type. A question you may be asking yourself is, what if I need to calculate the probability of two events that are not mutually exclusive? This is a legitimate question. Remember that not mutually exclusive events will have outcomes in common between the two events. The addition rule for any two events A and B for not mutually exclusive events is probability A or B equal to probability of A plus probability of B minus the probability of A and B. So again, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So let's take a look at an example for calculating probabilities of events that are not mutually exclusive. Suppose a single card is selected from a standard 52 card deck. We want to know the probability of drawing a king or drawing a diamond. These events are not mutually exclusive because the outcome king of diamond is in both events, so we need to use the addition rule. So let's first calculate the probability of drawing a king. We did this earlier. 4 kings out of 52 cards is equal to 4 out of 52, which is equal to 0.0679. The probability of drawing a diamond is equal to 13 diamond cards out of 52 cards. So that's 13 divided by 52, which is equal to 0.25. Calculating the probability of the king of diamond, there's 1 king of diamond out of 52 cards. So 1 divided by 52, which is equal to 0.0192. So the probability of A is equal to 0.0769 plus the probability of B, drawing a diamond, is 0.25 minus the probability of the king of diamond, the probability of A and B, which is equal to 0.0192. And when we add and subtract these from each other, we get a probability of 0.3077, right? So 0.0769 plus 0.25 minus 0.0192 is equal to 0.3077. What does this mean? The interpretation is there is approximately a 31% probability that we will draw a king or a diamond from a deck of 52 cards. Again, we expect that about 31 out of 100 draws, or 31% probability, to pick a king or a diamond from the deck.